Okay, so we're going to finish up module one with a little bit of detail on C++ style and how you can make your code more readable and more maintainable over the course of its lifetime. So one of the first things in regard to style and making code maintainable is to give meaningful names to the variables that are in your program. So your variables should be descriptive, rather than saying X or A or B or C. You might want to say speed or velocity or acceleration. Those would be more meaningful than just single letter variable. So you should be able to read the name of the variable and know what it means. The other thing is always have a C out that indicates to the user what you're expecting from them if you're getting input. So, for example, how tall are you? And in order from worst to best, these would be the choices. An underscore, not so good. Weight, that's pretty pretty descriptive variable name, but we're looking for how tall they are. And then later on, if you see weight and you go, oh my goodness, that's supposed to be height. It gets a little bit confusing. X, again, that's something that's a quick keystroke, but it's not very descriptive. And you would have to have a comment up top as to what X meant. H, it is the first letter of height, so that actually would be a little bit better than X. And then finally, height would be probably the best. User height, even better, because we're looking at how tall the user is versus how tall maybe an object in the game is. So someone who reads your code should be able to tell what it does without reading the assignment or a requirements document if you're doing this for a more formal project than what you're doing in CS1 and CS2. And again, you don't want to do things like this. This basically starts out like most of our programs so far with the pound include IO stream using namespace standard in main. And inside main, we have the answer to lab 3 is 45 plus 96 times 0.5. It may give the answer. That may be the answer that we want for lab 3A, but what does this mean? And we're not sure, what it actually means. What are we attempting to calculate here? Why are we calculating it? If lab 3A changed a bit, or I wanted to reuse this code for a larger lab or for homework assignment, how could I go about doing that? This, is definitely not programmer friendly. So someone who interacts with your code should be able to understand what they need to do without reading the assignment. So, or without reading the requirements document. So, again, here's some code. Again, this will compile and run, and this converts the number of feet entered by the user to inches. So we have feet and inches. Input feet, inches is 12 times feet, and it will say that equates to so many inches. The problem is that we're not telling the user what information they're entering. So, this will compile and run and it'll just bring up a blank prompt. And as the user, I say, well, what am I, attempting to do here? What information am I giving you? And afterwards, it tells you how many inches, and you didn't even know you entered feet. It could have been, miles, or could have been meters. Nobody really knows when they're running that program what is expected of them. There's a comment there that tells the programmer what it's doing, but it doesn't tell the user. So you want it to be user friendly as well. So, in general, don't do CN without doing C out to indicate to the user what they're typing in. And again, this is for the end user. Not everyone is going to actually read the code. And, again, don't assume the user is familiar with the assignment or the program that you're running. Tell them what it is they need to know. And in 150 and 151, you can have a little bit of fun and embellish a bit, but you don't want to get into the habit of being too snarky because it can come back to bite you if you're writing code professionally. And check the grammar and spelling. It's not really important for the comments, but it's important for the text that's shown to the user. So if you have a program, if you're running a program or an app and everything's misspelled, it might lower your perception of that app as a user. And we mentioned earlier that commenting is something that's really positive in programs, but overdoing it is, probably just as bad as underdoing it. I'd say underdoing it is probably worse, but over commenting is definitely bad. So, here we can see, where we're commenting every line of the program, even though a lot of this is obvious. For example, setting length equal to 4.0 in the first line, we can kind of see that from the code without having a comment, and the same thing for the cout statement. The other thing is that you want to do, and this is from a programmer friendliness standpoint, not a user friendliness standpoint, is dead code is bad. So here we start out with X and we set X equal to 1. Previously, we had set X equal to 2. And, that was incorrect, but we left that code in. So we weren't sure that the X is equal to 1 was going to work and give us the correct result. So we, kept the X equal to 2 because that was kind of close as to what we wanted. But after we're done, we get everything to work, remove that dead code. It can also take less obvious forms. So, here we have pounds and weight. What is your weight in pounds? We input the pounds and then it'll say, okay, so you weigh weight pounds. And this one's really, really confusing because you input pounds, but you never do anything with it because you have weight set to a constant 150. The other thing that can be bad in terms of readability from a programmer's standpoint is magic numbers, or sometimes more formally, they're called literals. Formulas like 354.1 times 12. What is the 354.1? We can actually make those into constants above the program and give them names. So, here we have const double rent is 354.1. That's pretty cheap, actually. And there are 12 months in a year, so your yearly rent is 12 times 354.1. And that makes a lot more sense than just putting in that formula there. And, again, the comments usually, or the constants usually go above main, and we'll talk about why we do that a little bit more later. The other thing is making good use of white space. And gaps can make your code much more easy to read. For example, it's good to have a blank line between the variable declarations and the actual computations. I tend to separate out the portions of my procedural programs, declarations of variables, getting inputs, making calculations and producing output. I tend to separate those. And later on, we'll see functional decomposition, which will make our programs even clearer. But good use of white space for these beginning procedural programs is definitely good. And even as you get into larger programs, you want to make use of that white space. And the other thing that goes with white space is indenting, and we'll get more into the indenting, but things should line up in terms of what goes with each control structure, what goes with each function. And again, the alignment and indentation, it's good to have the braces aligned. Over on the left, they're aligned. You can see the beginning and end, and you can match up what goes in between them. Whereas the ones on the right, C++ will take both, but it's not as obvious, and if you have a lot of different braces or a lot of different blocks, it can get confusing when they're not aligned. So, a lot of this is common sense, and you have two goals in mind. You want to make things readable for other programmers and usable for the end users. And, again, we want functionality first, the program that looks great and is user friendly but doesn't give you the correct results is not very good versus one that's not necessarily user friendly or programmer friendly but gives correct results. That's better, but we want something that's programmer friendly, user friendly, and gives the correct results. So that's it for this presentation. Thanks so much for watching.